Hi everyone, Dave Millington here. I'm the C++ Product Manager here at Embarcadero. Thanks for attending the webinar on TwineCompile. So TwineCompile is a fantastic plugin that integrates into C++ Builder and speeds up your compile speed. As you probably know, if you're attending the webinars, sometimes C++ can be quite slow to compile. It's the nature of the language. And TwineCompile aims to solve that problem and does so very successfully. You see some very impressive speedups. So fully integrated into C++ Builder. It's available to install through Get-It. It is free in Get-It if you have Active Update subscription, no matter what edition of CBuilder you have, whether that's professional or enterprise or architect. If you have Update subscription, you can download and install it right away. So we're very lucky to have online Jonathan Benedicto, the author of TwineCompile, and I'll hand over to him now for the presentation.
Thanks, David. I appreciate that. And let's just dive right into it. Hello, and welcome to this webinar on how to boost your C++ Builder compile speed with TwineCompile. TwineCompile is an IDE integrated plugin and build system that significantly increases your productivity when building and working on your C++ projects by increasing the speed at which your projects can compile and reducing the turnaround time to get your projects to run. It comprises a compile system that uses multi-threading and caching techniques to distribute your compile of your project across multiple processes and optimizes the file access through the caching system to make the C++ compile process run many times faster. Some users compiling big projects on AMD Ryzen Threadripper processors have reported compile speeds of over 50 times faster than the IDE's built-in compiler. This build system works with all versions of the C++ Builder compiler, so that's both the classic and Clang compiler, in both 32-bit and 64-bit. It's not only just a build system, though. TwineCompile is all about increasing your productivity as a C++ Builder developer. One of its biggest features is the fact that it enhances your IDE productivity by automatically using a very powerful background compiling system to build the files that you change and modify behind the scenes, so that when it's time to run your application and see your changes, the project merely has to be linked, because all your changes have been automatically compiled. TwineCompile also integrates directly into C++ Builder as an IDE plugin with automatic hooking of your projects so that you don't have to make any changes to take advantage of these features. You just click the Make, Build, or Run options as you've done before, and now the TwineCompile build process kicks in and automatically takes care of building, making, linking, and then running your application. And probably one of the best things about it, TwineCompile is completely free to all C++ Builder users that have an active 10.4.1 update subscription. You can go and download it right now in the Get It package manager under the IDE plugin section. Let's dive into seeing how TwineCompile actually works and how it can be used, how it integrates in the IDE, and the benefits that it provides. We'll start by taking a look at a fairly small project, 100 units or so. We'll see how it compiles using the IDE's built-in compiler. Then we'll install TwineCompile, going through that process, and take a look at the features and all the benefits that TwineCompile will bring in this simple project. Here is RedStudio 10.4 C++ Builder. TwineCompile is not installed, and I have my algorithms project open, which is over 100 units, uses a little bit of templates, a little bit of the standard C++ library. Shouldn't take too long to compile, but with the IDE compiler, it will take 4 minutes to compile. Let's go ahead and see this take place. So I've started the stopwatch at the side so we can see how long this compile is going to take. As I said, it'll take about 4 to 4.5 minutes, which is far too long. So I'm going to speed up the video. And while we're waiting for this to finish, even with the sped up video, I want to mention that I'm building this on my desktop workstation. Has a fairly late generation Intel processor that's reasonably fast. It's not the top of the benchmark anymore. As we'll get into later, it has 6 cores, 12 threads, because it's got hyperthreading. But obviously the IDE compile is single-threaded, and therefore it takes a long time to compile each file by itself. So as we're all used to, this is those times where you simply sit and wait for your build to complete. So there, a full build of this project took 4 minutes and 13 seconds. One of the things about this, of course, was the fact that I couldn't do anything while working on this project due to the fact that a compile was going on. The compile window sits in front of all my work, and I can't get around it. It's a modal window, and I have to simply sit back and wait for this to complete. Let's go ahead now and load up TwineCompile and see what it can do for us. I'm going to go to the Get It Package Manager, go to the IDE plugin section, wait for the plugins to be loaded. TwineCompile is visible here as an available IDE plugin. I'm going to go ahead and install it. Accept the license agreement. I need to restart the IDE. And the installer will start. Let's bring it over here. Let's open on my other monitor. The installation is very simple, very few options. Just installs, registers into the IDE, read the README, finish the setup. And of course, as it asked or mentioned before, it does need to restart the IDE. So I'm going to go ahead and restart it. Okay, the IDE has restarted. And the first thing you'll notice is that there is a new TwineCompile menu option. There are a number of options available under this menu, but we will look at that in a later time. Let's go back and open up our algorithms project. And without making any further changes or adjustments to it, let's build it now with TwineCompile and see just how fast a full build will take in comparison to how long the IDE took. I'm going to go ahead and click the IDE build command. And the first thing you'll notice is that a new compile window has shown up. This is the TwineCompile compile window. And as you could see, TwineCompile has automatically inserted itself into the build process in the IDE so that I can use the IDE's standard build, make, or compile and run commands. And TwineCompile will automatically take care of the compile and build process necessary before running the project, or obviously if you just click build, doing the actual build. It is immediately apparent that TwineCompile is significantly faster than the IDE, as it has just finished building the entire project in 42.5 seconds. You'll notice that there is also a new compile window, that is a compile message window, that has opened up as part of the compile completing, as there were 3 linker warnings. TwineCompile uses its own compile message window, as well as its own compile progress window, to provide a better experience with more features than the IDE's windows provide. All the TwineCompile windows are fully dockable using the IDE docking system. So we can go ahead and dock these windows into a place in the IDE if that's where we wanted to put them, instead of leaving them floating on top of our IDE. You can then save those docked windows or even the floating windows in the position of your choice as the IDE's desktop. And the IDE will take care of remembering where you had those windows and will automatically put them back there every time you start the IDE. Let's go ahead and dock these somewhere. Let's find a nice place to put them to demonstrate this. So if I go ahead and put it on the side of the project manager, and we can make this a bit wider, we now have the TwineCompile window to the side. No, that doesn't work so well. There isn't enough room there. Maybe what we'll do is we'll put it down here. That works. And we'll close the palette. So we have our build window below our project manager. And let's dock the TwineCompile message window with the IDE's message view. Bring up the messages pane. I'm just going to show it down here. And we can drag this in here and it will automatically show up as a new tab. And the problem with this is now we've just made our window a lot smaller. So for now, let's just close that out. If we go ahead and start another build, it will be immediately apparent that the build process is completely behind the scenes. I can still act and make operations in the IDE. I can open up a code file and I can make changes to it. This is because the TwineCompile build processes are inherently running in the background. And this allows you to continue getting your work done while the long build processes happen. The editor is fully functional. I can enter any text I like into the editing window of any unit that I have open, while the build process is seamlessly operating in the background. And then once the build process is complete, the compile message window is automatically opened, showing any of the messages, warnings, errors, or hints that I need to look at. Before I do anything else, I'm going to save this desktop so these window positions are remembered. Use the default layout. That way it'll always be remembered for my default view. All right. Let's take a look at some of the other commonly used build functions. For example, we've made some changes to this unit. So let's save these and do a make. You'll note that TwineCompile takes care of doing the make. It determines that we have just one file to compile, builds that file, and then links the project, just as you would expect from a make operation. TwineCompile has a significantly faster dependency check system compared to the IDE, which means the turnaround time for a make, especially with a project with many C++ files, is much faster. Twine can evaluate these using its caching system to make sure that the minimum number of file operations take place and the make can run extremely quickly. We can also do a build of a single unit, so compile unit. Once again, TwineCompile kicks off, builds the unit, and completes it. As you can see, TwineCompile has automatically integrated with the IDE so that all of my common operations which I can be doing as part of working on a C++ builder project have now been redirected to compile with TwineCompile, bringing all the benefits of TwineCompile to everything that I do while working on a C++ project without having to make any changes to the project, either manually or through some configuration, or by making any changes to the IDE. It just automatically hooks in, connects, and business as usual. You do your work, you work in your project as you've always done. TwineCompile does offer some configuration options. You can use these to tweak or adjust how TwineCompile works in the IDE and how it does perform its compiles, and can be useful in certain circumstances. let's take a look at the options which are available to us. Under the TwineCompile menu, there is the options, which brings up the TwineCompile Options dialog. The very first option that is available in this is whether TwineCompile is enabled. If we were to uncheck this and close the box, and now build our unit again, you will note that TwineCompile has disappeared, and the IDE has just built our file using the built-in IDE's compiler. This allows a very simple way to switch back to using the IDE's compiler if that is something you need at any point in time. TwineCompile also gives quite a bit of control over many of the attributes of the actual build. For example, on this very first page, we have threading. The thread count defaults to automatic, which means it's going to spin up as many threads as there are logical processes in your system. As I mentioned before, I'm running on a 6-core machine with hyperthreading, so that makes for 12 logical processes. So TwineCompile attempts to compile using 12 threads at the same time. You may have noticed in a build that I did a few minutes ago, there was a point where it appeared to stall for about a second or so. And this was obviously due to the fact that my machine was completely loaded down by having all the threads being used for actively performing compiles, and the UI could not keep up. This can interfere occasionally with the ability to continue working on your projects while all the CPU is being used to do the compile. So TwineCompile offers these options here, both the thread count and the priority, to allow you to control how many resources are allocated to the compile and what priority they get in case you need to make more resources available for continuing to work on your machine. TwineCompile allows you to choose how many threads you want to use, so we could reduce this and it will automatically take effect on the next compile. Alternatively, you can set the priority to either normal, below normal, or above normal. And this obviously can be used to deprioritize the compile so that you get more resources available for other processes, or to increase the priority so that the compiles take more resources and higher priority than anything else happening on the machine, which can be useful for things like build servers. There are settings available to control how TwineCompile handles the caching of header and source files in memory. It is important to note that TwineCompile relies on the cache to achieve a lot of its compile performance by caching frequently used include files and other infrequently modified files in memory, so it does not have to hit the disk to be able to retrieve these files for the compiler. Most of the time, these defaults are exactly what you want, but there are occasions for some very big projects or some special circumstances where you want to test out configurations that you may want to adjust how the caching happens. Under the plugin commands, there are more user interface related commands, although there is one option specifically for the build. The first option is whether or not to close the compile window after a compile has completed. Obviously, if you're using a docking layout, or you have the window permanently open on a second view or something like that, you don't want the window to close, you want it to stay open. But TwineCompile does offer the option to have it automatically close. You can also control whether the compile will stop after the first file that is encountered with errors, or you can let the compile complete for the entire project, and then all the errors encountered while compiling all the files would get omitted. Finally, there is a control to specify whether files are compiled without saving. As you know, one of C++ Builder's many features is the ability for you to compile and test projects without actually saving the changes in your files to disk. Many users use this functionality and find it very helpful, but certain workflows that some users have used and do use, they prefer to have the files saved to disk as part of the build. If you uncheck this option to compile the files of projects without saving them, TwineCompile will automatically make sure to save all your unsaved files to disk before executing a compile. And this affects both compiles, makes, and builds. There are some additional options to control the linker that you want to use for the build process, and then some user interface options for adjusting the presentation of errors and warnings on the compile message windows. Precompiled headers, there are some detailed commands here for tuning your compile. Far too complicated to get into for this discussion, but can be used to tweak and adjust how precompiled headers are used as part of your build to optimize it further. And then skipping over sorter compile, as I want to make that its own section, we go down to notification compile events. There are some compile events and notifications that you can set up to execute when the build completes. For example, a sound file can be played when the compile completes, or just like IDE build events, there are certain compile events that can be invoked as part of the build process. So before the project is saved as part of the build, when the compile starts, when the link starts, when the whole build finishes. Now we come to probably what is TwineCompile's biggest feature outside of the sheer build performance brought by the TwineCompile build system. And that is what we call sorter compile. What is sorter compile? Sorter compile is the TwineCompile real-time automatic background compile system, which automatically invokes itself based on numerous triggers and compiles your files behind the scenes while you're working on them, so that at any point in time, your project is fully compiled. So when it's time to hit make or run, all that has to happen is for the project to get linked. TwineCompile behind the scenes has made sure that your files are pre-compiled. So as you make a change, as you toggle between your units, as you edit your project options, the background compile process kicks off and builds the project behind the scenes, automatically making sure that your object files are always up to date with your CPP files. There are a number of triggers that sorter compile uses, and they're automatically invoked by the TwineCompile system. You can control which triggers are enabled at any one time. You can configure how long TwineCompile waits before reacting to a trigger. And there are some other options available for configuring this. The three triggers are, as you can see here, triggering when the project options change. So if you change some project options, such as C++ compiler options or include or something like that, TwineCompile knows it has to make the entire project and will automatically kick off a background make of the entire project. TwineCompile can trigger when the active tab changes. So as you switch between units, you make a change in one unit, you move to the next unit, TwineCompile automatically compiles the unit you just left. It can also trigger when the mouse and the keyboard is idle for a certain period of time. So you're making some changes in your code, you step back, you don't touch it for a little bit, TwineCompile kicks off and compiles your latest changes. And finally, the option which isn't listed here as configurable because it's always enabled, and possibly the most useful feature, sorter compile compiles and kicks in when you save changes to a unit. Let's actually see this in operation. So we go back to our algorithm's main unit, and let's take out some changes. We delete that. So we've made some changes to our unit. Now we save it. And you will note that the compile window has just told us sorter compile algorithm CP project completed, and it built the unit we just changed. And that automatically triggered when I hit Control S on the keyboard to save my changes. If I click the save icon on the toolbar, let's make another change, click the save icon on the toolbar, and you can see just as well, anytime the save command is invoked, sorter compile kicks off and builds the unit behind the scenes. This means now that at this point in time, my project has been completely made. There is no units that need to be compiled. If I go and do a make, all it has to do is link. So I don't have to wait for my project to compile any longer. It's always compiled as fast as I'm making these changes. The other triggers that we saw in the options, we can demonstrate. For example, let's make a change. Let's say done with no errors. And let's sit back, talk about this functionality, grab a coffee, something like that. Maybe I have made a change to my code and I'm just wanting to look through the changes that I've made. It's a big method, something like that. Or I'm reading some documentation. I'm talking to a coworker who's dropped by. You will note that without having to do anything, just by being idle, TwineCompile kicked off and built the unit automatically. Once again, I come back to my code and it's already built. If I were to hit run, if I were to do make, there's nothing to do. The file has compiled behind the scenes. Another feature that is useful with this is the ability to trigger when I make changes in one unit and then switch to another. If I were to bring up a second file, so here is a second file, registry.cpp. Let's make a change and then switch back to algorithms main. You will see that TwineCompile has automatically taken care of compiling the changes to registry.cpp without me having to instruct it or inform it. And once again, the project is completely up to date. There is nothing needed to compile. If I do a make at this point, all it has to do is link. And you actually just saw right now, TwineCompile checked due to the 15-second delay. Was there anything to do? There wasn't. Everything was compiled. At any point in time, it's making sure that my project is up to date and that when I'm ready to actually run my code, all I have to do is link it. And this takes the whole turnaround time out of working on projects, because at any time it's fully built behind the scenes. I make changes, I hit run, it links, I'm done. I can see the changes immediately. And this is an enormous productivity enhancement tool. One question that may be raised with this functionality provided by the background compiling is how it could potentially interfere with work in progress. For example, you're working on some code. Perhaps there are some compile errors you're working through. For example, let's make a compile error in our code. I'm going to save all units just to reset state. Now I'm going to make a compile error and I'm going to build the unit. This is an explicit build. I said I want to build this unit. This wasn't a TwineCompile build. We can see it completed and we got, as expected, our error message saying I left out a semicolon. I'm working through these compile errors now. But what happens when TwineCompile kicks off while I'm working on this and perhaps reports other problems in the code as I'm working through these compile errors? For example, let's go to registry.cpp and let's do the same thing. Let's take out our semicolon there as well. And that was an accident. I didn't mean to do that or something like that. But I'm currently working on this algorithms main. I don't want those background compile messages to interfere with the work I'm actively doing because I'm currently working on this error that I've encountered in algorithms main. You'll note that although I made that change in registry, which obviously would have failed to compile, and I've switched back to algorithms main, you saw TwineCompile did build registry, and more importantly, it failed. It did not replace the compile message in the compile message window. That compile message still shows the error from that manual build that I invoked. And this is a deliberate design for this very reason. when you have a background compile process going, you don't want it to interfere with things you may be working on, such as an active set of compile messages. So compile by default, and there is an option available in the TwineCompile options to change this behavior, emits compile messages into a separate compile message window so that you can distinguish between errors and warnings discovered by your intentional compiles that you invoked and the errors and warnings which the background process created or found. And that is what's called the sorter message pane. So the current compile messages window that you see up on the screen is the normal message pane. This contains the compile messages, errors, warnings, hints that your invoked compiles produced. The sorter message pane contains the compile messages, errors, warnings, hints that the background compiling process compile produced. If we open this up and bring it over here, you will see that compile has found the errors in both files. And this was a completely separate set of messages to the message which we manually made appear by doing an explicit build. So this way you can see the errors and the problems being discovered by the background compile process without it interfering with the work that you're actively doing in the code base. We can dock this one, let's say dock it to the right of the compile message, and this way you can see the errors which you're going to have to deal with in the future, or the errors which may be dependent on changes that you're currently making in the unit. For example, if you're working on a header file, you make a change and it breaks, say, 5 or 6 other C++ units, you'll see those changes, those errors in those other 5 or 6 units. When you fix the header file and it's complete, then you'll see those errors disappear. And by that, you'll know, what sort of changes you have to make to get your project to compile successfully. For example, if we go back to registry now, let's fix that problem, put the semicolon back, and complete the build, or rather I should say switch the tab back, compile completes the build, and you'll see it automatically did its build as one would expect because we flip between the tabs, and that other error has disappeared now because we've just made the change, it backward compiled and removed that error from there. Compile is kicking off again because you're being idle for so long. And obviously I can fix this error here because I can see that the background compile process found it as a problem. Let's save all our changes. Compile kicks off, builds both units. The compile message pane is now completely empty because there are no problems discovered by the background compile process. Our intentional compile message is still there because we haven't executed a make or a build to clear out those messages. But we can see from the compile window that there are no problems, that we've solved them, we've dealt with them. And if we now do a make, it'll clear out our compile messages, we'll get our link, and we'll end up with our linker warnings as we expect. As you can see from this, compile makes some significant productivity improvements to your C++ development workflow. It automatically takes care of making sure your project is always built and up to date. It separates messages and errors and warnings discovered across your project by the background process from messages that you may be actively working on. It allows you to see at any time what potential problems you have in your code base that you need to fix without getting in your way. And in real time, shows you those errors and warnings so that as you fix them, as the code base starts compiling, you can see what's left to work on or what outstanding problems there are until, as we have just seen right here, there are now outstanding problems and we end up with a code base that was fully built. And when I did the make right now, all it had to do was link. There was no compile that needed to happen because, once again, compile behind the scenes took care of making sure that the files were always up to date. Just think of it. No more C++ compiles. Everything has happened behind the scenes without interfering with your workflow. The only thing you're going to see from now on when you do a run or a make is the link process. And because the link process is generally a fraction of your build time for a large C++ project, this represents a significant improvement in both productivity and the turnaround time available when working on your C++ code bases. Okay, so that takes care of, say, the day-to-day C++ development, the tasks you do, the way you work when creating the project, working on the project, editing it continuously, things like that. What about build servers, continuous integration, stuff like that? Can TwineCompile be used for those command line builds, those builds done through build systems like Final Builder? Absolutely. TwineCompile, at the end of the day, is fully integrated into the MS Build process. It uses standard MS Build targets based on standard MS Build assemblies, and it is very easy to integrate it into your build process. There are a couple ways you can do this. One is to edit your project to pull in the correct TwineCompile targets, execute MS Build, and TwineCompile will automatically spin up and do your builds. However, there is a much easier way. TwineCompile bundles our command line build and make utility. And this command line build make utility automatically takes care of invoking MS Build for your C++ Builder projects or project groups, doing all the necessary configuration, setting up all the necessary properties that you need to run a C++ Builder compile through MS Build. And as any of you know who've done it, there are a number of setup tasks. You've got to set the right environment variables. You've got to do things like that. And our command line tool called JtMake automatically takes care of these configurations and also automatically makes TwineCompile the compile process used to build a project. Let us take our algorithms project and run it through JtMake so you can see just how simple it is to invoke. So I'm going to bring a command prompt window over here. I have already added JtMake to the path. And if we just run it, we will see that there's a number of options available. Not many, it's fairly simple. Basically, JtMake put some options saying you want to build a project, make it, what compiler version, what RAD Studio version you want to use, and then pass in the project or project group file name. So for this, let's say JtMake, I want to build it. This is 10.4, and I'm building algorithms.cvproj. Hit enter, and JtMake has automatically fired up MS Build, building this algorithm CVProj using MS Build and using TwineCompile to run the build process. As you can see, these are compiling very fast as it's compiling it across all the processes available in my system. And this obviously gives you real-time output of the compile process, but being a standard MS Build execution provides all the detail and control that you can expect from an MS Build project. In addition, because it is MS Build, it supports all of the functionality available in MS Build that you can include in your project. And there the build is completed. We have our 3 linker warnings that we've seen before from the IDE. And that's all there is to it. JtMake has taken care of doing everything necessary to build this project. I didn't have to make any changes to it. It correctly configured the project and built it, just like the IDE plugin does. In fact, actually behind the scenes, JtMake is basically just a command line version of the IDE plugin. We use exactly the same logic, and the code is shared between the two to make sure that building the project on the command line builds it in exactly the same way as it would build in the IDE. This is somewhat different from how RAD Studio operates, where there is a subtle difference between how command line builds execute versus IDE builds. So this provides consistency and simplicity to your build processes. So there you have it. Brief rundown of all the advantages and the performance that TwineCompile can bring to your C++ development. As you can see, it's extremely easy to install, to set up, to use, and it brings some significant enhancements to both your day-to-day development processes and procedures, things you do for your continuous integration builds, and of course, just the sheer compile speed. Your project turnaround, the time it takes you to build your projects, all of that has been significantly improved, enhanced with all the features that TwineCompile brings. And don't forget, as I mentioned at the beginning, this is available as a free download for anybody with an active C++ Builder 10.4.1 subscription. So go to the Get It package manager and download it today. And now I guess we'll take some questions.
All right, thank you, Jonathan. That was a really impressive video. It's a really impressive plugin as well. I'm a big fan of it. A lot of questions came in actually. I saw you were answering some during the video. What I might do is run through them, and if you wouldn't mind sort of answering them now in the live Q&A.
Yeah, sounds like a good idea.
Fantastic. There's a question here where the example you're using had a precompiled header and asking about what improvements is seen using the precompiled header wizard.
Right, so obviously, it goes without saying, correct precompiled header usage has an enormous effect on compile times. This was true back in the legacy classic compiler days, and continues even with the new Clang-based compiler. So not all projects can take advantage of precompiled headers. That is absolutely true. But if your project can take advantage of precompiled headers, use them, set them up, be disciplined with continuing to use them. TwineCompile is built around precompiled headers. It obviously works without them, but it is deliberately tuned and optimized to maximize the use of precompiled headers, and will give you even incredibly faster compile times when you use precompiled headers, because it allows the precompiled headers basically reduces the work the compiler has to do, which means it can compile files faster, which means when TwineCompile kicks in, it can distribute those files, it can cache them, it can balance them, and just make them go much faster. This particular project did not use precompiled headers deliberately, because if I did, it would have compiled too fast for the sake of demonstration. Yeah, that's about all I can say on that, I think.
I think compiling too fast for demonstration would be pretty impressive, actually. Sort of related to that, there's a question about the test system's hardware specs, whether it was using SSD, how much RAM.
Yeah, obviously, similar to precompiled headers, if you're not using SSDs for your C++ projects, upgrade immediately. SSDs make an enormous difference. I've run all these demonstrations off SSDs. This is not SATA SSDs either. These are PCI Express SSDs. So really, really fast. Test system is an Intel 3930K processor. It's a couple years old now, but still fairly good in terms of threading performance. And the machine has 16 gigs of RAM. So it's a fairly large machine with pretty fast capacity disks, fast processor, and more than enough RAM to be able to take advantage of the caching systems.
All right, good to know. So you'd recommend people use, reasonably decent systems to take advantage of TwineCompile?
I mean, TwineCompile is going to help you no matter what system you use. It's going to provide that sort of gain, but the better the system you can use, the better your results are going to be. And I have a case in point. I have a customer who decided to upgrade their system to an AMD Ryzen Threadripper, processor, which has 64 cores, plus what the AMD dual thread system, similar to Intel's hyperthreading. So 128 logical processors. They took on that project, it went from a 3.5-hour compile time down to 5 minutes with TwineCompile. So yes, get yourself a big, powerful machine and put TwineCompile on it, especially with the emphasis the modern processors have on multi-core.
All right. Yeah, I remember using TwineCompile myself actually many years ago. I think it would be 2008 or something like that, perhaps. And obviously the machines that I had back then were significantly less powerful than the ones available today, and it made a huge difference. Even on what my today is pretty, pretty poor hardware. There's a question as well comparing the compile speed to batch compilation. So it asks, how is the compile speed compared to when batch compilation is set to use a certain number of subprocessors?
Right. So batch compilation was added back in, I think C++ build 2007, something like, maybe it was 2009. And basically is similar to the gcc-j command, which essentially just breaks the project up and cuts the files out and distributes them between multiple processors. And it works. I mean, it's going to be faster than the regular compiling because it's using more processor power, but it has a couple problems with it. One, it's not very intelligent, so it doesn't automatically distribute the load around between the processors as jobs complete. It also doesn't take advantage of knowing what jobs are going on what processes to be able to redistribute the files effectively to the fastest process or thread that can compile them. Both of those things TwineCompile does. So there is still a significant performance advantage when using TwineCompile because it has a much more intelligent build system. And more importantly than that, batch compiling does not actually support all of C++ Builder's features, specifically features related to local file options and things like that, which often big projects tend to use. And that functionality is just simply not supported. TwineCompile fully supports all of those C++ Builder features. So if your project compiles in the IDE right now, TwineCompile will compile it as is. There will be no change you need to make. That one of the big goals behind this was making it 100% seamless. So there's no compromises you need to make in your project to be able to use TwineCompile.
Yeah, you're right about the limitations that batch compilation has, and I think TwineCompile's, the extra magic it has sometimes provides much more significant speed ups than the batch compilation could. I mean, with batch compilation, you would never get to a 50 times compile improvement, for example. There's another question here on precompiled headers, although I think it's similar to the previous one, effectively asking, should we keep precompiled headers or not?
Right. So yeah, obviously, as I said before, always use PCH if you can. And I think the question specifically is referring to the TwineCompile option, which we kind of briefly looked at. I didn't really go into any details on about keeping precompiled headers for a certain number of compiles. And this was it's not really a performance option, it's a support option. We have encountered many situations, especially in the past. I think the newer compilers are a lot more stable in this regard, but after a while, very large projects would tend to corrupt their precompiled header files. And TwineCompile gives this option to automatically clean up precompiled headers, so basically restart them from scratch after, say, 100 compiles or so, and that can be configured so that you never run into the corruption issue. Like I said, that was more for the really, really big projects where this can happen. If this is not something that's happening in your projects today, you don't need to bother with it.
Alrighty, thanks. There are a couple of questions here that I think are feature requests, actually. There's one about sort of compilation status, to have an OK button when compilation is done.
Yeah, this is a feature request that goes way back. Most users like docking the compile window. That's one feature we should like showing off, because it really emphasizes the background compiling aspect. So Twine never gets in the way of your work. It just sits to the side. So it's never a modal window. But some users like to have the window pop up, and they like to close it out. And although you can just close out the window or move it to the side, or even tell Twine to close it automatically, it has been requested to add the OK button just as a more of a consistency item. So we've thought about it. We haven't done it yet.
Sure. There are a couple of questions here that I think are for me. So there's a question: it's a tool that can really leverage C builder productivity. Yes, actually, that's a statement, not a question, but I have to interrupt the question to agree there. Yes, it's quite an amazing tool. The actual question following that, though, can leverage C builder productivity. Is it also supposed to be available for all the next releases, such as 10.4.2? And follow-up question about why is this a separate add-in? Why is it not directly inside the IDE? So in terms of being Get-It, it is in Get-It if you have update subscription currently. We haven't decided how long it would be there. I guess, Jonathan, we need to discuss that. I myself would certainly love to see it remain in Get-It. I think it's a wonderful tool. And in terms of why it's not in the IDE directly, well, look, adding something like this is certainly of strong interest to us. And I think that if you think that this belongs in the IDE, then I would request that you email me. Things like that happen based on based on customer interest, basically. So if you think it should be in the IDE, please let me know. And my email there is david.millington@embarcadero.com. So yeah, definitely encourage everyone who's listening to do that if you think it should be inside the IDE. As a plugin, though, I think it's very impressive. I've written a few IDE plugins myself, and this is an outstanding one. I'm not sure I could have written this. It's really brilliant. Back to questions for you, Jonathan. There's a question here that when you use TwineCompile, the CPU usage quickly goes to 100%, which is good because it's using all the resources available. But the PC sometimes feels like it's freezing or hung while compiling. Is that expected, and how can you handle that?
Yeah, and obviously this is the classic problem you immediately run into when you use all the resources finally, and it's fantastic, but you realize, wait a minute, I actually used those resources for other things that I no longer can do. And yeah, I mean, obviously in some cases you want the compile to do everything, but especially as we started going in through this video and looking into the fact that you can really utilize the background compiling and sort of compile to keep working while the compiles go on, becomes apparent that maybe using all the resources is not such a good idea. And in those cases, it all depends on the workload. Some projects, due to the way that they compile, they can be more disk intensive versus CPU intensive. So in other words, the compiler is busy crunching files rather than doing actual compilations, or turning text into machine code. And if that's the case, you probably find that Twine doesn't hang the PC because you're waiting for the disk all the time. The compile is so fast, but it's background IO wait, so it doesn't block the PC. On the other hand, if you have a project which is that compiles in a more CPU intensive manner, then yes, you will run out of those CPU resources and things will start hanging and freezing. You even saw in the video, there was a brief moment in one of the compiles where the UI just froze for a bit. So in cases like that, just adjust your thread count. You know, tune it, tweak it, adjust it. No CPU and no project is the same. You know, sometimes if you've got like a hyper-threaded processor, all you need to do is release one thread. So if you've got, you know, 12 hyper-threaded threads available, going down to 11 unlocks it enough. Sometimes you have to unlock 2 to release an entire logical processor, or rather a core, I should say. But yeah, that's what the option's there for. Play with it, find out how many resources you need to keep doing your work.
Yeah, I think that's the kind of thing you see with a lot of very CPU-intensive apps. Video encoding, for example, and things like that will often, you know, saturate the CPU. And of course, for speed, you're trying to saturate the CPU. You're trying to get as much to happen as possible. But yeah, I think it's great you have the settings there to tweak that so that your other software can remain responsive while it's working hard. There's a question here about the caching system. So there's basically asking how does the TwineCompile file caching and Windows file caching compare to each other?
Yeah, so and it's a good question. It was one of the things that we have worked on over the years. I mean, TwineCompile actually, you know, dates from 2005, 2006, when they're beta testing through all the functionality out on the C++ builder newsgroups back in the old newsgroup days. And it was always a big question, you know, why does Twine need its own file caching system? You know, Windows already has a file cache. What's the point of that? Aren't you just using up extra RAM because now you're caching in 2 places? And we didn't build anything in here without testing it thoroughly. And what we found is that there is a different use case between the types of file operations that generally happen across an operating system, which the Windows file cache is geared for, and the specific file operations that a C++ compile uses. There's certain sequences, there's certain things that a C++ compile does, which if you tune and optimize the cache to deliver on, it does deliver a much better performance. And that was proven hands down, even in the old pre-SSD days, because even with the old spindles, Windows file cache still existed. And it was used to good effect to optimize the use of the spindles, but the Twine cache made a significant difference there. SSDs have changed the game somewhat. SSDs are ridiculously fast. And they even have onboard RAM caches, which cache significant amounts of the drive in their own local RAM. But we find that the Twine cache still impacts that and makes it work better. And you know what? Go ahead and try it. There is an option in the TwineCompile options to turn off the file cache and drop back on the Windows cache. So that's basically telling Windows to do the caching. And you'll notice the difference. With the Twine cache enabled, it won't be significant. Like, I'm not going to say it's going to be like 50 times slower, no. But there will be a noticeable difference in the performance without the Twine cache enabled.
A couple of questions here about the availability of TwineCompile. So someone who's using Seaboarder Tokyo and 10.3 Rio, whether TwineCompile is available. So I can answer part of that. Oh, sorry, Jonathan, if you want to answer first.
No, you can go ahead.
Yeah, I was just going to say that in terms of being in Get It, so freely available in Get It, it's only available if you have active update updates. Pardon me, I can't speak today. Active update subscription. Yeah, and Jonathan, I'm not sure, the version we have in Get It, is that targeted only for 10.4.1 or 10.4x? Or
Yes,
will the installer install for everything?
No, it's targeted at 10.4.1 and higher. So
Right.
You know, if you install any of the patches and updates, it's going to work with those, but it doesn't support the prior versions.
Sure. So yes, earlier versions, I mean, yes, you can get it for free if you have 10.4.1 and update sub, but what about earlier versions?
Yeah, so if you want earlier version support of TwineCompile, we at JtMake do offer that. It's a separate purchase you would have to make. You'd have to basically buy a TwineCompile license. And the TwineCompile 5 version goes back, it starts at 10.2 and goes higher. And then for earlier versions, we also offer our TwineCompile version 4.5, which was the previous major release. And that supports versions of C++ Builder from C++ Builder 5. Yeah, that's really C++ Builder 5, all the way up to 10.1. So basically, there is TwineCompile available for whatever IDE you're using.
You mentioned that TwineCompile works really fast. They downloaded it from Getit, as I understand the question, downloaded during the talk. And 10-minute compiler link time went down to less than a minute on their Threadripper computer, which is really great.
Yeah, I can highly recommend those Threadrippers. Looking forward to seeing the new ones, which are supposed to come out in the third quarter of this year. But if you're doing C++ compiles, yeah, go with as many cores as you can, which of course means stay Threadrippers. So they can do fantastic things.
There's a question here as well about using it with CMake. Is it possible to use TwineCompile in a CMake build?
Yes, it is. At the end of the day, and this is something we didn't really get into in the video, but at the end of the day, TwineCompile is basically a drop-in replacement for both BCC32.exe and BCC32c.exe, the underlying compilers for the C++ Builder compilers. So if you have a make build process, you name it, that at the end of the day calls one of those two executables, you can drop in TwineCompile at that point and it will work. It's designed to function that way. So yes, you can absolutely integrate it into your CMake builds. There's no, I'm not going to say that you can use JtMake for that. No, JtMake's only designed to build MS build project files. But you could change your CMake build, your CMake project to be able to call TwineCompile instead of the regular compiler.
That sounds good. I think I'll have to try that out myself. Yeah, CMake is very useful for a lot of the sort of more open source sort of C++ libraries. Yeah, knowing they work together is really good. Getting to the end of questions. So if you have questions, please type more in. There's a question here. Sometimes C Builder projects have Pascal, Delphi files in them as well. Basically asking how well that works. The actual question here is saying that this person has an issue, but I think it's better to ask the question for everyone of does TwineCompile support PAS files?
Yeah, and it obviously does. Not that it's going to compile them using a multi-threaded process. No, that's specifically only for C++ files. But one of the big reasons behind it made TwineCompile development quite a bit more complicated. But one of the reasons why we went with the MS build process was so that whatever happens, whatever your project needs to do as part of a build, as long as it's doing it through MS build, just like the IDE does, it's going to be supported TwineCompile. So that means, if you have a C++ Builder project that has Pascal files, assembly files, resource files, even custom file types, you introduce a custom file type, you add your own custom task into MS build project that does some translations, maybe if it's doing translation file generation, code generation, something like that. Because TwineCompile runs MS build, and it sits inside MS build, and of course the plugin runs the MS build process. Anything that MS build will do on your project that you could compile using MS Build in the command line or in the IDE will work through TwineCompile. If there's some specific issues that you run into in doing this, obviously reach out to us. It's not intentional. It's just a problem, a bug, something like that. Everything is fully supported and will work.
That's good to know. And yeah, I agree there that having it integrated with MS Build makes it significantly more powerful. I mean, MS Build is a powerful build system you can do all sorts of things with. So yeah, having it work there is very good. There's a follow-up question here about again about getting it for an older version with Tokyo, and I think the answer there, Jonathan, is to go to Geometech's website.
Yeah, visit our website. You can download the trial version there or purchase a license, and that'll get you full access to that.
There's a comment here from someone who is moving from the classic compiler to Clang, and has found the combination of TwineCompile with Clang has made that much easier. Have a very large set of projects, a very large project group. So that's really good to read.
Yeah, and that's exactly one of the cases, as this comment mentions, where sorted compile is invaluable, because you're working through a big refactoring like this. And as you're doing this and maybe working through some code issues, or you either have a list of errors you have to fix, or you're just refactoring the code base. You can keep glancing at the sorter message pane and seeing what errors you've introduced, what things still need to be fixed, basically giving you this live progress on how well your refactoring is going on. So yeah, this is exactly one of the cases where that functionality is a huge time saver, in my opinion.
And a final question just came in from someone else who downloaded it from Getit during the talk, saying thank you for a really nice tool and that it works for compiling my large scientific libraries. That's great to hear. Look, I've reached the end of the questions that have come in, scrolling through. So if you have any more questions to ask, please type them in the question area. And just while we're waiting there, perhaps for another minute or so, just let any more questions come in. Just a reminder that this is free in Getit right now with, if you have active update subscription. So just go to Getit, you'll find it in the IDE plugins section. And if you think that we should include, this functionality in the IDE itself, as I mentioned earlier, that kind of thing, really comes from customer feedback. So please give us that feedback. I think the best way to do that is to email me. My email is david.millington@embarcadero.com. Jonathan, just while we're waiting for any further questions, certainly like any comments or anything that you want to say, or any questions you want to expand on, or anything like that?
I can't think of much at the moment. I'm going to reiterate, something which I say to everybody, comments, questions, suggestions, feedback, everything is absolutely welcome. One of the interesting things about working on a project like this is you're actively trying to solve real world problems that people are encountering. Trying to make their lives easier, trying to make the whole productivity and experience of working on C++ projects. And I'm sure we're not all here because let me rephrase that. I'm going to say we're all here because we enjoy working with C++ and all the things that it provides. And we just want to find out ways to do better. And the best way for us to be able to help you with that is to get feedback and comments, suggestions, positive or negative. It doesn't matter. It's still feedback. And that helps us, deliver a better product. something that solves more needs. So please, reach out if you have anything to say whatsoever, and we'll definitely be happy to hear from you.
I think that was very well said. I couldn't add to that myself.
So I see one comment came in about.
Sorry, go ahead.
Yeah, about whether Twine is a framework around the Clang or Classic compiler, or whether it's a new other compiler. And this is something that periodically comes up, and I think sometimes the name and the way it works gives people to think that perhaps TwineCompile is actually a different C++ compiler, and it isn't. TwineCompile is a wrapper or a framework, if you choose to call it that, around the Clang and Classic compilers. At the end of the day, it's those compilers that are doing the actual code work. Twine just makes sure that they can use as much of the processing power as available, that they don't sit waiting for the disk, that they always have a file to work on. But at the end of the day, it is the Clang or Classic compiler that takes your source code and turns it into the binary code. This is why there is no problem with project compatibility, compiler options, needing to make sure that you're going to get the final binary output that you expect your code to have. Twine doesn't do any source code modifications. It's merely feeding the source code into the Clang or Classic compiler, the Embarcadero compiler. It's just making sure that that happens as optimally as possible.
Yeah, and I think there's, from my understanding there, Jonathan, there's quite a degree of integration into the IDE as well, because both our compilers, both Classic and Clang, can, when compiled within the IDE, actually work as a DLL that's loaded into the IDE. Of course, when you compile on the command line, it's they work as normal executables, and TwineCompile sort of inserts itself using the same system, but still uses the IDE's own own compilers there.
Yes, and that's a very good point. There's more to TwineCompile than just the process of actually compiling the files at the end of the day, as you say. There are two pieces to it, especially with the sort of compile productivity enhancements that's delivered by the IDE plugin. So the two pieces work together. There's the IDE plugin, which provides a much better and more productive build experience, project workflow experience. And then there's the compiling side, which takes your C++ files and builds them as fast as possible. And the two separate pieces work together. But at the end of the day, what they're doing is making sure that what needs to be compiled goes through the Clang or Classic compiler as fast as possible.
All right, and there are a couple of suggestions here for you about documentation as well. Someone found a how-to on your website.
Yeah, should just update that with the latest information, because sometimes that gets out of date.
Sure. There's another comment here that I think is a feature request around the windowing in the IDE to make it easier to find the compile or sort of windows.
Yeah, being related to the IDE's docking system, TwineCompile really doesn't have anything to do with that. TwineCompile windows are just dockable windows in the IDE. So any windows are visible under the IDE's window menu. Just bring that up to bring the windows back up. TwineCompile does also offer those options in the menu, its own menu, to open up the compile window or the two different message pane windows if you close them, in either deliberately or inadvertently. So those between the IDE's dockable window support and those specific TwineCompile options, you can always bring the window back.
All right. Look, I think we're running right to the end of the questions here. And we are about 20 minutes over time, so it's probably time to call the webinar to an end. Jonathan, thank you very much for the webinar. I've found it really impressive. I find the whole plugin itself very impressive as well. I'm a big fan of it. So thank you very much for taking the time to run the webinar and stay for the Q&A and everything like that. It's much appreciated.
And thank you for giving the opportunity to be able to present this. I really do appreciate that. Appreciate all the support and feedback that I've been getting. It's been fantastic to work with you guys and to make this available for the C++ Builder users.
Well, same here, and look forward to it continuing. Well, thank you, everyone. We'll see you at another webinar in future. Have a good day.